Hello everybody, my name is Elton Searsley and I work for Think Big Analytics. Today we're going to go over how to create a Kylo standard ingest data feed. We're going to go into a couple of the specifics on standardizers, validators. We're going to talk about the difference between a feed, a reusable template, an NiFi template, and a Kylo template. So without further ado, let's go ahead and start. So whenever you want to create a new feed for standard ingest, you should know that standard ingest comes in two parts. There is in NiFi the reusable part of the flow, which for standard ingest is inside of reusable templates and then standard ingest. This part of the flow is triggered concurrently depending on how many pipelines are running at once. The number of flow files that can be coming through here can be anywhere between 0 to, let's say for now, 1,000. The way the flow files actually get into this processor, that's where the other half of the pipeline comes from. It's the part of standard ingest called pre-processing, and it's a pre-processing feed. Now, you see there's a lot of arrows here leading from these processor groups. These are our different categories in Kylo. We have category for Toy Store, category for Test, one for IBS, and one for Concerts. These lines, what they're actually connecting is the input and output ports from the pre-processing template that standard ingest uses. For example, here. We'll go into this. So restaurant inspections, this is a pipeline that we have already created. Inside of this pipeline, this is not standard ingest. This is a part of standard ingest, but this is not the whole entirety of it. In our case, or in the instance of this pipeline, the only processors that we execute and use are get file, update attribute, which this sets a whole bunch of different attributes that this specific feed with its specific hive schema and all these other attributes that are particular just to this feed. These are all set at the beginning of the pipeline, and then because standard ingest is expected to run in a way that receives all these different parameters and then will process the data accordingly, this is pretty much all the pre-processing template does. It'll get the file, so it has a physical file to pass on to standard ingest. It'll update or initialize the feed parameters, which will say this file's table is restaurants, or this file's schema is restaurant ID, customer ID, and then whatever fields might be in that file. In this case, we're saying restaurant inspections, and the restaurant inspections file that we have has, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's like 15 columns, and these are all 15 of the columns that have to do specifically with our restaurant inspections feed. And these attributes are configured through Kylo. When you go through the wizard of setting up a new standard ingest feed, one of those steps is to go through the table creation wizard, which will actually populate and fill in these properties for that feed when Kylo goes and creates the NiFi processors in NiFi. So with that out of the way, you can understand that the way standard ingest works is in this test section we'll get our file and we'll set our attributes, and then inside of here we have an output port which says to standard ingest. You can see that up here. So if we back up and we look at this output port that says to standard ingest, we see that it doesn't actually go to anything still. Well, there's another output port inside of this category section that also goes to standard ingest. So if we had a whole bunch of these and they all route out to standard ingest, they'd all route out to this output port. That output port routes from the categories processor group called test, and that actually goes into reusable templates. And the way it connects is, let's see here, to input standard cleanup. Okay, that's not the one we want. Well, there's two here. They're stacked on top of each other because it's two different relationships. But the one we're going to actually look at, I guess, instead of standard ingest, will be standard cleanup, which will say inside of this we also have standard cleanup, and it goes out, connects into reusable templates, comes in through this input port because this arrow is going away from the port this time, and actually comes in through this standard input port or this standard cleanup port, and we'll go into standard ingest, and then from there the standard cleanup input port will go and drop the table and the HDFS directories when you delete your feed. But anyway, that was to kind of give you an idea of the dependencies for standard ingest. There's a pre-processing feed and there's an actual processing feed which will handle uploading the data into HDFS, splitting it among its different tables, and ingesting it into the core data warehouse zone. Without further ado, we're going to create a new instance of that pre-processing feed that feeds into the reusable template of standard ingest. So basically, whenever you need to go and create a new standard ingest pipeline, all you're actually creating is that preprocessor section, which initializes what table and what all the different parameters for that table are for the specific file that's in question. So to create the feed, we'll go into Feeds under Feed Manager and hit plus, and we'll go to Data Ingest. We'll name our data name, we'll do Restaurant Inspections. Well, actually, I already have one named Restaurant Inspections. We'll just name this one Inspections. Inspections. Food. Because it is just food inspections. Okay, so we'll do food inspections and then test. We're going to be what the name of our feed is. We'll go on to the next step. File system. We're going to name this food inspections. Var drop zone is where we're going to look. So this selection option in this pre-processing template gives us two options. One is database and one is file system. We're going to go with file system, but to quickly go over database, and that was that that top portion of this pre-processing template handles that. These top four processors. If you click on database, then you're going to need to have some sort of database to select from. We have Kylo MySQL, but that's the metadata repository for Kylo. There's not really going to be anything we can use in there. But if you were to use that, then you'd say that, you put in your table name here, and then you'd say either full load or incremental. And then depending on how often the pipeline runs, it'll either fully replace everything in there in the destination table, or it will, based on a watermark, go and load from wherever it previously stopped, and then it'll bring new data into your warehouse. But for our example, we're going to use file system. So now continue on to step 3. We have a sample file. We're going to say sample.csv. These are the different columns and data types that Kylo has inferred now from that sample file. In our sample file, I believe our fields were pipe delimited. No, they were comma delimited, and there wasn't anything special about it. There's no partition column or anything like that. But when Kylo went in and tried to infer the data types on each column, we can see here that camus is an int, zip code's an int, phone's a double, score is an int, and everything else is strings, which is fine. We'll just keep the schema as that. And then on define table partitions, here we can do add partition. Now, if we had, we don't have any date time fields in here, but if we had a date time field, for example, if inspection type resolved to be a, let's see, date, or if it resolved to be a timestamp, is either one of these, then you could go into the next column and say, okay, for that timestamp of inspection type, we're going to say day, and that will be dy. We'll add 2 more fields. Inspection type month, and then we'll name this MO, and then inspection type year. We'll name this year, and that's how we could get a derived partition period based on a column that we get, or based on a column that we're ingesting. But since that column was resolved out to be a string, we're going to go ahead and remove these partitions, do expand, turn this back to be a string. And then in the partitions tab, we're just not going to have anything. Then over here in the feed options, we're going to do skip header because we do have a header column, or we do have a header row in our data. And we'll continue on to the next step. Now, this step allows us to decide what columns we want to profile and index. Typically, we just profile all the columns because it's not really that's not really too big of a deal. Granted, if your data files are really big, then this could slow your pipeline down a little bit. But, we're just going to go ahead and profile all the columns, and then on index. Wouldn't recommend indexing all columns. Instead, just kind of index a couple columns you think are useful, like DVA, Boro, and Canvas. If I'm looking at the data, I know that, oh, well, actually, you can look at the data too. By clicking on these different fields, since Kylo already inferred your data types, you can click on these different columns and actually see the sample values over here. So you can see Boro actually means like city. So we have Manhattan, Queens, and Staten Island, and Brooklyn. So we're going to index on Boro, we're going to index on DBA. What's DBA? DBA is the name of the restaurant. And then Canvas is like the ID of the inspection or something. It's like the instance ID. We actually don't need that. We can do building, street, and zip code. For right now, we're just going to index 2 columns. And we're going to profile all the columns. And then the other option we have here is standardizers and validators. So let's say for this phone number, and let's see what the, yep, just a 10-digit phone number. So in this phone number we can do add, and we can say validation. We're going to add a validation rule that says length, max length is 10, mid length also 10. We're going to do add rule. We can add another standard or another validation rule if we want for this specific column, where we say maybe we want to make sure that the field being passed through is a date. We would just pass this in, and it validates the it will validate whatever string is in that column against date. In this case, we know this will never actually be date because it's a phone number, so we're gonna say not null. Allow empty string values no, trim string values yes. We're going to add that rule too. So we want length to be 10 and we don't want it to be null. I mean, if it's not 10, then obviously this is technically also failed too, so it's a little redundant, but I'm just kind of showing an example here. And then standardization, we can add standardization policies which will reformat the column. maybe we want to do strip non-numeric. Actually, let's edit it. Let's edit a different field here. Oh no, I didn't. Okay, so I gotta add those back on real quick because I didn't hit apply. Length 10, then 10, add rule, done. Okay, so on this we have one validators. That was actually the wrong column, so we're gonna remove it. Go down to phone, add validation onto that instead. Length 10, 10. Okay. And then the other one we'll do, let's see, score, standardization. We're just gonna, if the value is null, it will use the supply value. So rather than doing some sort of validation on here, this is just saying what default value do you want for any of these columns that you have. We're going to say for score 0. Add that. See, okay. Now for merge strategy, which is the next section. Okay, so we're done with these now. We've added a standardizer and we added a validator. And now for the next section, for choose merge strategy, we have 5 options here. Now, depending on which option you pick, obviously the data is going to be handled differently. Previously, in one of the other steps, we were able to select and deselect primary keys. I just went back a step, where we can select primaries. I guess we can use that as a primary key, Camus ID, because it's a unique identifier, and then we'll go to next. Now, we can use merge using primary key, which will basically say delete all other records for this primary key and insert the new records. It's kind of like an overwrite partition. There's sync, which it's a full rewrite of the whole table each time a new data file comes in. So it'll overwrite your existing content. Merge, it won't do anything special other than merge the data into your existing table. If they're duplicates, then you're going to have duplicates from that point on. Dedupe and merge. With dedupe and merge, usually it runs on. Usually you'll run dedupe and merge on a partition, but and that's what rolling sync is. But if you're not using a partition and you still want to remove duplicates, you can use dedupe and merge. Rolling sync replaces all records in the partitions that were passed in. It will replace all existing records with the new records. Okay, and we're going to actually just say sync because we only have one file that we just run over and over again. And then in target format, we're going to say parquet. Compression option snappy. Snappy is really the only option we have here. It works with a lot of different other formats. Hyde likes it. Hadoop likes it. So does Spark. Parquet is the optimal format for Spark if you're expecting to run Spark jobs off of this table eventually. You can look into the other target format types and what their advantages and drawbacks are. Now we'll go into the next step where we do business properties. We add a data owner. In this case, it's just going to be me. And we'll add a tag here for food. This pipe will run every 5 seconds. And we go ahead and create it. Okay, so now we have a created pipeline called food inspections. Let's go into jobs and just make sure that we didn't somehow get an execution of that pipeline kicked off. Even though we know there's no file to kick it off with in there right now, I just want to make sure. Okay. So now go back to Feed Manager, look at Food Inspection, and let's see what the input directory and file filter were. Food inspections.csv unless the named in bar drops out. Okay, so I'm going to open up my Windows, my Linux terminal, and in here I'm going to go to var drop zone, and I'm going to vi, I'm actually just going to cp sample, and I'm going to do that. Chown, NiFi, everything. Alright, so now with that, my pipeline should kick off because we have a file in there. There it is. Food inspections has started. So now we have a standard ingest job ingesting this food inspections file. I expect it to take about 1 minute and 40 seconds. But while it's executing, we can look at some other things. For example, Kylo allows you to look at the job details or all of the currently being used attributes in the pipeline through its UI by clicking on job details. And if we scroll down through here, we can see the feed name is test food inspections. Creation time of the file was just a minute ago. File is owned by root, also owned by root. Permissions, that file name, food inspection CSV. Now we can also go into step details, and this will show us where in the pipeline we're currently executing. Now with the pre-processing template you saw before, it's only these first 3 steps that are being executed in there, and then it's going to the output port. Because that port's connected to a reusable template in NiFi, that is why Kylo is able to track the steps from that part of the job and all the different steps from the reusable template part of the job. Because Kylo knows that both separate pipelines exist and that they connect to one another, so it's connecting. It's just well, actually, Kylo just follows the unique flow file ID through NiFi. Whenever it detects a flow file for a specific pipeline has been executed, it'll basically take that flow file ID and track it through provenance on all the processors that are associated with it. And the provenance is basically a run history inside of each processor. If you haven't seen that before, you can view that by looking at any processor and going to right-click, and you can go to Data Provenance. And inside of Data Provenance, it'll show any flow files that have passed through this processor lately. Anyway, that's how Kylo tracks everything. It looks straight at the Data Provenance. So it won't know. So Kylo won't know that a processor is executing until it's done executing. That's why in the UI here we see that the pipeline is completed, but if it's in the process of running, and for example, if it's in the process of executing the merge content processor, we'll only see execution up to here with the execution time, and then once this one finishes, we'll have a finished execution time here. Okay, so this pipeline finished ingesting. We can go ahead and open back up our Linux command line and type in beeline. And then we do connect. And I think it's TBC Hive. Oh, yeah. Oh no, Hive 2. Yeah, there we go. And since no Kerberos or anything is activated on this cluster, and there's no authentication set up, I was able to just hit enter twice with no username and no password. But that's fine. We'll do use test, show tables. We now have food inspections. We have all 5 of the tables associated with that. If you haven't seen the my video on how standard ingest works and how these tables, what these tables are for, then maybe you'll want to take some time to watch that video. But for right now, we're going to do select count from food inspections. Now this is probably kicking off a MapReduce job. Or the beeline connection that I made isn't quite right. Here it goes. Okay, so we have 399,626 rows in this table. That means that it went through the validation and went through the standardization, and these records all passed. So this 399,626 records, these are all valid records you can use to generate reports or run analytics against, anything like that. The other tables that were in there, in case you haven't seen the breakdown of how standard ingest works, the feed table is the raw file. As soon as the data is loaded into HDFS, a partition is added to this feed table with the raw survey, the raw Hive survey, which is basically how Hive reads the files, and if it's CSV or if it's Parquet or whatever. In our case, our files are CSV, so this feed table is a CSV table. From there, standard ingest filters the feed data into valid and invalid based on the standardization and invalidation rules. And then any rows in the valid table are then loaded into the inspections table as the core valid data set. The profile table, that's populated after the valid invalid is run, and this is just generating some statistics on each of the different columns. It doesn't actually look like a data table, it's more of a report table. Here we can actually query that real quick and say select star from limit 1. Okay, so in here we can see basically just some ultra basic information in the profiling table. Kylo reads this and makes a little more sense of it, but anyway, that's basically it for the creating your first standard ingest pipeline. I hope it makes more sense to all of you. If you have any questions, feel free to reach out to me at eltonsearcy@teradata.com. Thanks.